All right, so today is April 9th, and we are going to be talking about area of sectors and arc length. Okay, so this goes back to circles. So we're going to start with sectors and what that is. So let's define it really quick. A sector is a section of a circle bounded by a central angle. Okay, and if y'all remember, a central angle just goes to the center, and its intercepted arc. Okay, think of a sector like a slice of pie, slice of pizza, okay, whatever. Okay, the formula to find the area of a sector. All right, it's going to be area is equal to x, which stands for the degree measure of an arc, times pi r squared over 360. Okay. So let's look at a couple examples. Let's look at number one. So I'm going to go ahead and just copy my formula again, just so it's easier for us. Okay. BC is 16, so that is going to be my radius. So I have area. Okay, and if we remember that whatever the angle, whatever your central angle is, it's also going to be the same as that intercepted arc. So this arc degree is 51 degrees. Okay, so that's 51 times pi times 16 squared all over 360. Okay, so I'm going to simplify the top a little bit. So I get 13,056 pi over 360, and then I'm going to put that in my calculator. You could put the entire thing in your calculator. It's fine no matter what. Okay, and that gets me about 113.94 feet squared, and I am finding area. Okay. All right, so number two. So PQ is 22. So this time they give me this central arc, and it's 139. So that means its intercepted arc is also 139 degrees. Okay, so here's my formula again. Okay, so I get 139 times pi times 22 squared all over 360. This time I'm going to put that straight into my calculator. Just make sure you use parentheses, otherwise it will not work. So I get area is equal to about 587.09 centimeters squared. Okay. Number three, so JK is 3 millimeters. So same kind of thing where this is 84. So its intercepted arc is also 84 degrees. Okay, I'm going to plug it into my formula. So 84 times pi times r squared over 360. And I get 6.6 millimeters squared. Okay. Number four, so they tell me YZ is 9. Okay, now here's the thing. I want to find the shaded area. Okay, well, a circle is 360 degrees around. So if this is 42, to find the shaded, I'm going to do 360 minus 42, and I get 318 degrees. So my intercepted arc is 318 degrees. All right, and then I plug it into that formula. So x is my intercepted arc degree, which is 318, times pi times r squared, so that's 9 squared, over 360. and that's about 224.78 inches squared. Okay, and y'all, I'm just putting that into my calculator. There's no need to do it by hand when you have a calculator and you're able to use it. Okay, number 5. So ST is 32.5. This is 29 right here, so its intercepted arc is also 29 degrees. So area, actually let me write my formula real quick. Okay, so area is equal to 29 times pi times 32.5 squared all over 360. Plug it in, and it's about 267.31 feet squared. Okay, number 6. So this is 72. Its intercepted arc is also 72. JI is 15.1. So my formula, so area is equal to 72 times pi times 15.1 squared all over 360. So that's going to be about 143.26 inches squared. Okay. All right. A couple of the problems that you'll see is that if you are given more than one shaded sector, so like on number 7, okay, well, in the middle I have vertical angles, so this is 46, this is 46, okay. So there's a couple ways you could do it. You could either break it up or you could add them together and then do it. I'm going to go ahead and add my 2 intercepted arcs together. So 46, 46, that gets me 92. So that's going to be my x, so the measure of the arcs, okay? So I'm going to do area is equal to 92 times pi times r squared, which in this case is 7, all over 360. Okay, plug it into your calculator, and you should get about 39.34 centimeters squared. Okay, another one that you could see is like number 8. So again, make sure you pay attention to the shaded. Okay, so I know that these are both 17 degrees, but I want the shaded. So I'm gonna do 360. Actually, you could just do 180 minus 17 because that is a diameter. So I'm just gonna do that. I'm gonna do 180 minus 17, and you get 163. So those are both 163 degrees. Okay, so then my intercepted arcs, I'm going to add those two together. And this is what I'm going to be using for x. So that's going to be 326. That's going to be my x. RS, so y'all got to be a little careful because if you try to trick y'all, RS is 43, which that is that entire thing. So that means my radius is half of that. So that's going to be 21.5. So then I want to use my formula. So my area, my x we said was 326 times pi. My radius was 21.5 squared all over 360. Okay, enter that straight into your calculator, and you're going to get somewhere around 1,315.05 meters squared. Okay, so that's it for sectors and finding areas of sectors. Okay, so for arc length, basically what that is, it's the length of an arc is a proportion of the circumference the formula for that is L is equal to 2 pi r times x over 360. So x again is same as it's the degree measure of an arc. Okay, so let's look at our first example. So again, I'm just going to copy the formula down here. All right, so EB is 15, so that's my radius, and I want to find the length of CD. So I want to find that arc length. So to do that, I need to first find this angle, okay? So to find that angle, I just do 180 minus 68 because it creates a straight line, and I get 112. So the arc is also 112 degrees. So then I have everything I need. I just need to plug it in. So my length is equal to 2 pi. My radius is 15 times 112 over 360. And it's okay to enter it in your calculator just like that. So I'm going to go ahead and do that. You actually get 28 pi over 3. Sorry, y'all, I'm trying to find my answers. Okay, and if we were leaving it in terms of pi, this is what I would expect. But since I'm not, sorry, I'm having some Wi-Fi issues. Okay, sorry guys, that took forever. So I get about 29.32 centimeters. Okay, I promise I'll speed up on the rest. So in the next one, VS is 12. So that's actually a diameter. So my diameter is 12, which means my radius is 6. And I want to find the length of arc UT. So that is this guy right here. Okay, so to do that, I first need to find the arc length, or sorry, like the arc measure. So to find this piece of the puzzle right here, I do 180 minus 127, and that gets me 53. And since this is 90, I'm just going to do 90 minus 53, which gets me 37. Okay, then I plug it into my formula. So length is equal to 2 pi. My radius we said was 6. And then times 37 over 360. Plug it into your calculator. And I'm going to get about 3.87 meters. Okay, number 11. So FG is 27, that's a radius. Find the length of arc FED. So I start at F, go to E, go to D. Okay, well I know this piece is 90. So to find the remaining piece of the arc, I'm going to do 47 plus 80 plus 90, and then subtract that from 360. And I get 143. So then add 143 and 90, and I get 233 degrees. So that's going to be my X. Okay, plug it in. So I get length is equal to 2 pi times 27 times 233 over 360. right, and I'm just going to plug that straight into my calculator. Just make sure you're using parentheses, and you should get 109.8 yards. Okay, and then the very last one, so JH, so that's the diameter is 21, so that means the radius is half of that, which is 10.5. And I want to find the length of KJG. So K to J to G. Okay, so an easy way to do this one, from here to here and here to here are vertical angles. So to find just this piece right here, I'm going to do 85 minus 59. And I get 26. So this arc is 26. To find arc KJG, I'm going to do 360 minus 26, and I get 334 degrees. So that's the X that I'm going to be using. So I'm going to put it in my formula. So L is equal to 2 pi times 10.5 times 334 over 360. Okay, plug it into my calculator, and you get about 61.21 inches. Okay, and that is it for today.